Good morning, all. Welcome you all for next lecture series. In this series, we are going to discuss about transient response. Is our unit fifth unit. In that, we have to discuss especially about DC response, that is transient response for DC circuit. And today we are going to discuss RL circuit. This RL circuit means before enter into this session, we have to recall what is inductor. What is inductor? As it is a device which stores the energy in the form of magnetic field. And we know that the relationship between the voltage and the current for the inductor, it is V is equal to L into di by dt, and time constant for RL circuit, and how it is here for the steady state. These are the topics we are going to discuss, and this is a RL circuit under the DC excitations. So first you have to see the circuit diagram. There is a switch is there along with this resistance and inductor are connected in series with the battery that we called as the DC source. So before that, what is meant by transient? Yes, it's a response in the circuit to sudden change in the input or switching condition. It's called as the transient. So if you're considering this circuit, if you are closing the circuit suddenly, then what will happen in the circuit that we have to see in this lecture series. That first we have to apply Kirchhoff voltage law in the circuit. Write the equation. That is V is equal to, we know that R into I plus L into di by dt. So applying KVL, V of S is equal to in the time domain in the Laplace form. V of S is equal to R I of S plus L into LS into I of S. So I of S is equal to V by S divided by R plus L of S. So from that we are finding out the value of I of S. And the next will be taking the partial fraction for the above circuit. That is I of S is equal to V by R 1 by S minus 1 by S plus R by L. And for this equation, we are taking inverse Laplace. So inverse Laplace is in the form of time domain, is in the Laplace form, S domain. So I of t is equal to V by R. The same thing we have to keep like this. So 1 by S, instead of 1 by S, we are putting 1 minus 1 by A plus, that is A plus A, e power minus AT. That is the formula. So based on this, we are writing minus e power RT by L. And this is a response characteristics. First, we have to analyze the current rises exponentially, that is t is equal to 0 and t is equal to infinity. When we see the diagram, that is the first is the voltage and the second one is the response of power. And the response of voltage, we are seeing this, if your current is 0 and that is increasing, that is VR is increasing, because the resistance to dissipate the power, and for the VLS, the maximum to decreasing gradually to the 0. So this is what happened when t is equal to 0 and t is equal to infinity. Likewise for the power, the power based on the inductor restores the energy. No, that is first you have to increase the power attain the maximum. After that it will be reduced. So for the inductor it is increasing and reaches the power maximum. That is I is equal to V squared by R, and it is L is equal to this is the empathize parts, and this is a defining part of RL, and it's a pain point, partial fraction, initial condition for handling, and time constant response. So, and this is the applications for RL for real world. We're applying RL for real world is relay circuit, solenoid actuators, DC motor starting circuit, electromagnetic systems. And these are the diagram where I have to show for you. And summarization, what is RL circuit with the DC source, conditions, analyzing the method, and response in the applications. These are the few reference for all, and thank you. See you in the next video.